Hi class, today we're doing theoretical probability. So you should be at the theoretical sections of your notes. We will be covering 2 pages of this and then you'll have homework. Theoretical probability is the odds that it will happen, not what actually happens. So theoretically, you should get heads and tails 50% of the time. Heads 50%, tails 50%. If you actually flip it 10 times, you're probably not going to get 5 tails and 5 heads. So the theoretical is the 50-50. What actually happens is the actual probability. All right, let's get moving. Okay, the probability is a measure of how likely an event is to occur. The set of all possible outcomes is called the sample space. So like in our heads, tails, the measure of how likely an event occurs is 50-50. The set of all possible outcomes would have been heads, tails. That would have been our sample space. So our sample space would have been heads and then tails. This would have been 50% for each. For equally likely outcomes, the theoretical probability of event PE is the ratio of the number of favorable outcomes to the total number of outcomes. So ours, it's 1 to 2 is our ratio. Okay, a jar contains 32 red marbles and 28 blue marbles. What is the probability that a randomly selected marble is red? So when you look at this, you take 32 and 28, and we have 60 total marbles in our jar. So it's out of 60, whatever our chances are. It said red, so the red marble is 32, so we have 32 out of 60 is our probability. That reduces down to 8/15. Okay, pause and try yours. The restoration has 11 numbers. What is the probability of selecting a vowel? When we look here, we have 1, 2, 3, 4, 5. So 5 out of 11. A day in the month of January is randomly selected. What is the probability of selecting a prime number? Well, now you're going through your 1 through 31, because January has 31 days in it. So I have 31 days. Out of those 31 days, who is prime? So you're actually doing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, and 31. Now remember, 1 isn't actually a prime, so it doesn't count. Because the definition of prime is 1 in itself. So we have 2, 3, 4 is not prime, 5 is prime, 6 is not prime, 7 is prime, 8, 9, 10 are not prime. 11, 12 no, 13 yes, 14 no, 15, 16, 17 yes, 18, 19, 20, 21, 22, 23 is a yes, 4, 25, 26, 27, 28, 29 is a yes, 30 and 31. So how many do we have? And just count them out. 1, 2, 3, 4, 6, 7, 8, 9, 10. So we have 10 prime numbers. All right, you should have a picture of 2 dice. It's on the back of your packet. What is the probability the sum of the 2 dice on the next roll is at least 9? So that means my dice. So if you looked at your dice thing, you have all your dice in a row, right? You have your pictures here. And you have 1, and then you have 1 and 2, and you have 1 and 3, and then you have 1 and 4, and you have all your pictures that you're looking at. Now, and then I go 1 with 1. Oh, wait, I can't draw on this one. So this is with 1, this is with 1, this is with 1, this is 1, all the way down to 10. I want to know what is the probability the sum of the 2 dice on the next roll is at least 9. So this means it's 9 or more. So it's greater than 9. So my sum has to be greater than 9 or equal to. So when I look at my dice, I just count them up. So I know I have 36 different rolls I can roll. The first one that I have that equals 9 is 3 and 6. So we go to 3 to 6, we count the rest of them, and you should have come up with 10 out of 36 can be greater than 9. Out of those 10, we reduce that to 5/18. Drawing a heart or a club from a standard deck of cards. All right, we know that there are 13 hearts and 13 clubs in a standard deck of cards. So when you look at that, there's 26 hearts and clubs out of 52, which is 1/2. You could have also done it, I have 4 suits in a deck. Okay, I have 2 out of the 4 suits, which is 1/2 also. 8 books lettered A through H on the shelf. If Scott randomly chooses 2 books, what's the probability that he chooses A and B? So out of my 8 books, this one's a little tricky. He chooses books A and B. So I want one option, just A and B, and this is a combination on the bottom, because now out of my 8 books, I'm choosing 2, because the order does not matter. So out of all these orders on the bottom, I have one option that works, and this is really 1 out of 28. Okay, that one was tricky. I hope you did well. All right, I don't know why it does that. I'll have to figure that out. I'm in a different program, and it is not happy with this one. And I'm wasting your time, which really irritates me and mine. All right, here we go. Complement of the event is the probability of the event not happening is what we're looking at here. So complement is the opposite of it not happening. So if there's a 30% chance it will rain, its complement is a 70% chance that it will not rain. Since the sum of the probabilities in the sample space is 1, the probability of event not happening is, it's written like this, P not E, not of the event, is 1 minus the probability of the event happening. So we've done that already when we talked about the rain. So the probability that it will snow tomorrow is 7/20. What's the probability that will not snow? Well, that's the exact opposite. So 1 minus 7/20 is, so there's a 13 out of 20 chance that it will not snow. Okay, try your 3. Okay, the month of the year is random selected. What's the probability of getting the month that does not begin with a letter A? So I know I have, whoops, sorry, I wrote it in the wrong spot. Okay, so I know I have 1 minus how many start with the letter A. So out of my 12 months, we have August and April. So out of those 2, of it not happening, so out of 2/12, we're going to end up with, 10/12, which reduces to 5/6. Okay, look at the spinner on the left. Find the probability that it lands on a number that is not prime. So what's the chances that it lands on a prime number? So go 1 minus. Okay, we already talked, 1 is not prime. 2 is prime, 3 is prime, 4 is no, 5 is yes, 6 is no, 7 is yes, 8 is no, 9 no, 10 no, 11 yes, 12 no, 13 yes, 14 no, 15 no, 16 no, 1 no. So we have 1, 2, 3, 4, 5, 6 that are prime. You could have easily have counted these the other way and not done all this work, which would have been fine. So you got subtract out yours. Did I count these right? 1, 2, 3, 4, 5, 6. So you subtract out your 6, so you got 10 out of 16. That our prime reduces down to 5/8. Okay, this one here, 2 dice are rolled. What's the probability of not getting doubles? So, well, the probability of getting doubles, so we know out of 2 dice. There's 6 of them. So we got 36 options of rolling. 6 of those will be your doubles, your 1s, your 2s, your 3s, your 4s, so on down. I should reduce this and make my life a little easier. Actually doesn't matter. So if we actually subtract this out, this is 30 out of 36. You could have reduced that too and had 1 out of 6 and had 5, 6 here, or reduce it here and also get 5, 6. Both ways work. Okay, compound events is something, and then the next one happens also. So when the outcome of one event does not affect the outcome of the other event. This is an independent event. So rolling a dice and picking a card, they do not affect each other. So if I want to get a 1 and an ace, this would be an independent event that's compounded. When the outcome of one event does affect the other is a dependent event. So let's say we have the probability of drawing an ace and I keep my ace in my hand. Well, that affects my rest because now instead of having 4 aces in the deck, I only have 3 options for the next. So that's a dependent event. Okay, we're going to talk about independent first. A die is rolled 3 times. What is the probability of getting 1s on each roll? Well, it's 1 die, so what I roll the first time doesn't affect the second time. Well, the first time I can roll 1, 6 because I have 1 out of 6. The second time I can still roll a 1 out of 6. The third time I can still roll a 1 out of 6. You multiply those options and then getting 3 1s in a row is 1 out of 216 are your chances. Okay, a coin is tossed. Then a day a week is selected. They do not affect each other. What is the probability of getting tails? So that's 1/2. Then a day starting with the letter T. Well, I got 7 days. I have Tuesday and Thursday, so that's 2. Multiply this out. Those actually cancel. I have a 1/7 chance of doing both of those. All right. I don't know why this does this. Here, let's pop. Okay, I hope you did well on your 4. When you look here, you had purple then yellow. The key in this one here is a crayon is selected and then replaced. So since it's put back, it does not affect my next selection. So we had 14 out of 32, then 6 out of 32 because you added them up. There's 32 crayons. And then I'm hoping you're typing into a calculator that reduces for you, which gives you 21 over 256. Green was the same way. So now you took green, which was 4. You took your times your red, which was 8. You got 1 out of 32. 2 purples, since you put them back, did not matter. The same with the yellow. And on the next one, the part that's nice about this one here is the crayon is selected. It is not replaced, which tells us these are dependent. So the same colors. So we're looking at these, and we've got a yellow, then a red. So you have 6 out of 32 yellow because they're all there. Then when you choose your red one, I have 8 red ones, but now there's only 31 in the bag. So that changes my odds here because they are dependent. Type that in, you get 3 out of 62. Okay, now let's do the purple. The purple, there's 14 out of 32 to start with. Green, there's 4, but then you choose another one, there's 31 left, which gives 7 out of 124. Okay, 2 reds. This is where I really wanted to go. To get 2 reds, you have 8 out of 32 to start with. You chose one of them. That means there's 7 red left, and there's only 31 in the bag. So both of them change this time, giving you 7 out of 124. All right, try your 3. The greens, you should have had 4 out of 32, 3 out of 31, giving you 3 out of 248. Okay, draw a card. Not replaced is the key. Another is drawn. What's the probability of choosing a heart, then a spade? Well, I know that there's 13 out of 52 hearts in a deck. I know there's 13 spades, but if I already chose a heart, there's only 51 cards left in the deck. So that's 13 out of 204. If you're having trouble, find a deck of cards and do this. Okay, Jack has 4 Snicker bars and 8 Mars bars. He randomly choose. Oh, there's only supposed to be 1 8 here. I forgot about that. chooses a piece of candy, ate it, then chose another. Okay, so when we first start, both were Snickers. So we start with 4 out of 12. He chose a Snickers, so there's 3 left, and he ate it, so there's only 11 left to choose from. Multiply that out, and you get 1 out of 11. I hope you did well. All right, it is homework time. Make sure you check your answers on the website and do a great job. It's going to be in the Google Calendar. Thank you.